number 1. Alex's baseball helmet is struck upward with an initial velocity of 90 feet per second from 700 feet high.
So the first point says write the position equation. So to get that, we use this formula. This is gravity over 2, and because it's in feet, is 32. So 32 over 2 gets us to minus 16 because it's going downwards, plus the initial velocity that is there, 90 feet, and plus the initial position that is 700 feet.
Find the equation of the velocity for the helmet using the derivative definition with limits. According to the derivative definition with limits, the function is f of x plus h minus f of x over h. So we write limit when h approaches 0, and here our variable is t because of time, and we just add h. So we have minus 16 times t plus h squared plus 90 times t plus h plus 700, and then plus 16 t squared minus 90t minus 700 over h. Then we solve factorize this, and we have t squared plus 2th plus h squared, and then we solve the multiplications, minus 16 times this plus 90 times this and that, and we get 16t squared minus 32th minus 16h squared plus 90t plus 90h plus 700, blah, blah, blah. And then we eliminate, minus 16 goes out with 16t squared, then minus 90t goes out with plus 90t, and 700 goes out with minus 700, and we get minus 32th minus 16h squared plus 90h over h. Then we get common factor of h, and we have h times minus 32t minus 16h plus 90 over h, and we substitute h with 0, and we get the velocity function.
The point C says that we have to explain the meaning of the potential velocity. To have the velocity with the derivative or with the function of velocity, you obtain minus 32 times t plus 90. Then you substitute the equation that's 0. You have to equal the function to 0, and then you isolate t, and you have this result, which is 2.8125 seconds, which is the time you spend to get to the highest point.
The point D says calculate the value of the maximum point of the helmet. So to get to the result, you have to use the position equation, which is the first one, and then you substitute for t because you got it in the point C. So you substitute, and it gets s times 2.8125 equals to minus 16 times 2.8125 squared plus 90 times 8125 plus 700, and then you get 826.6625 feet.
Calculate the value of the impact velocity of the helmet. First, to calculate the impact velocity, we need to calculate the time, and for that we use the general formula, and we get minus 90 plus minus the square root of 90 squared minus 4 times minus 16 times 700 all over 2 times minus 60. Then we have minus 90 plus minus the square root of 8,100 plus 44,800 all over minus 32. Then minus 90 plus minus square root of 52,900 all over minus 32, and in this part the the time divides in two roots. And the first one we use the plus sign, and we have minus 90 plus 230, that is the square root of this, over minus 32, and we get minus 4.37 seconds, and the other time is minus 90 minus 230 over minus 32, we have 10 seconds. And because it is physics, we cannot have negative time. And then we substitute the obtained time, that is 10 seconds, in the velocity function, and we get velocity v of 10 seconds equals minus 32 times 10 plus 90. Then we have v of 10 seconds equals minus 320 plus 90, and the impact velocity is minus 230 feet over square, feet per second.
The point F says that calculate the value of the acceleration of the helmet after 2 seconds. To get the acceleration, we have to derive the function of velocity, and you have minus 32 feet over second square.
Deciding if the helmet can still be in one piece after hitting the ground, we cannot know if the helmet is going to be in one piece because we don't know the materials.